Good evening, everybody, and you're very welcome to our second chemistry webinar. My name is Conor Walker, and I work with the Folan's Post-Primary Publishing team. And I'm delighted to be joined again tonight by our authors, Declan Kennedy and Ryan Gallagher. Looking back a couple of months now, I think our last webinar with Declan and Ryan was at the start of the new academic year, where the new specification was being implemented for the first time for fifth years, and we talked about the new edition of Chemistry Live and how to possibly plan out the first term for fifth year for the new curriculum specification. So this webinar will pick up where we left off to look at practical work through our newly published laboratory investigations notebook. And we'll look at the online resources that we have and are in development for Chemistry Live, as well as answer any questions that you might have. The webinar itself is likely to take less than 45 minutes, and covered in the presentation, Declan initially will bring you through the practical laboratory work that is covered in the laboratory investigations notebook for Chemistry Live. And he'll also touch on certain aspects of, I think, the sample exam papers from the SEC. Then Ryan will take you through the online resources that he's been working on for Chemistry Live and what's in the pipeline also on that front. Then we'll answer some of the questions that you posted to us in advance of the webinar. And if we've time for further Q&A, we'll also take those questions at the end. So if you have any questions, you can post them through to us by clicking the chat button and posting a comment through to the author team. Before we get started, just to avoid interruption, I'd recommend turning off messages and banner notifications during the webinar. So to do that, you just need to click your profile picture at the top right of your screen. And if you set your status to do not disturb, that should silence all team notifications, including any pop-ups that pop up during the course of the or would pop up during the course of the presentation. We will be recording this webinar and we will circulate that shortly after we finish here this evening. And we'll also share the PowerPoint slides with everybody who's registered, and you should have those in your hands by tomorrow. So with housekeeping and introductions out of the way, I'll hand you first over to Declan for the first part of the presentation. Over to you, Declan.
Great. Thank you very much, Conor, and welcome everybody. It's great to see so many of us online tonight. So if we could have the first slide there, so please, Conor. So what we're going to do is we're basically going to do three things tonight. Firstly, I want to bring you through the lab notebook, which hopefully you have all received now, the laboratory investigations notebook for the third edition of Chemistry Live. And then Ryan will bring you through the online resources that are available on the Folan's website. And then we'll go through some questions that have come in and answer them, and various other questions that have arisen perhaps during the webinar itself. So the next slide, please. So as you're all probably aware, the third edition of the laboratory notebook is now published, and this has been updated in the light of the new syllabus, or the new curriculum specification as it's called. Next slide, please, Conor. Now, if we just have a look at the table of contents of this new laboratory investigations notebook, there are 9 new experiments on the new curriculum, on the new syllabus. And that is experiment 4. I've put a ring around the new ones. Experiment 4 there, the law of conservation of mass, verifying it. Number 5, the serial dilutions of a stock solution. Experiment number 9, determining the concentration of a solution of ammonia. Experiment number 15, investigating the effect of surface area or particle size, more or less identical to what's on junior cycle science, as indeed is the conservation of mass experiment. The next new experiment is experiment number 19, to investigate the heat of combustion of a series of alcohols. Now, experiments 21 and 22 are in fact made up of a number of experiments. as you're aware, there's a lot of emphasis in the new syllabus regarding electrochemistry. It's probably one of the biggest changes in the new syllabus. And there are basically three experiments that the students should do: constructing the galvanic cell, constructing the voltaic pile, and investigating displacement reactions. In other words, experiments involving basically generating electricity, electron transfer. Experiment 22 then looks at what happens when we do the reverse. Instead of generating electricity by means of a chemical reaction, we use electricity to bring about chemical reactions. And there are three new experiments: the electrolysis of acidified water, as it was in the old syllabus, investigating the electrolysis of copper chloride solution, which is brand new experiment, and investigating the electrolysis of potassium iodide solution, as it was in the old syllabus. Experiment number 24, a brand new experiment, preparing an ester using a reflux method. So the old method where we just did this in a test tube scale is gone, and now it's a full experiment. And experiment then number 25, a new method of preparing soap on a small scale using household reactants. So those are the 9 new experiments. Next slide, please, Connor. If we look at how these are described on the curriculum specification, we see that in some cases, as highlighted there on the right-hand side of the screen, it tells us that experimental investigations are denoted by the superscript EI. Now, the following experiments are shown there. Experiment 1, which is the cation test; experiment 2, which is the anion test; experiment 4, the law of conservation of mass; experiment 10, which is the ethanoic acid in vinegar experiment; experiment 12, percentage of iron; experiments 15, 16, 17, and 18 are all rates of reactions; experiment 19 is heats of combustion; and experiment number 20 is a new experiment, enthalpy of neutralization. Now, all of those experiments are labeled as EI experiments. But in fact, I would recommend that all experiments should be taught in an investigative manner, and using this, what's often referred to as an inquiry-based approach. And that is why the title of what was called the laboratory notebook is now called a laboratory investigations notebook, because we are emphasizing the investigative or the inquiry-based approach. Now, the reason we are doing this is because when we look now at the types of questions that turn up on the sample papers, we have used this approach throughout the laboratory investigations notebook, asking students like, how would you describe the color of the flame? What is observed when acid is added to the marble chips? What color change is observed when the acidified permanganate is added to ethene? What do you observe when the sodium sulfite is added to the conical flask in the oxidation of phenylmethanol to benzoic acid? Describe what you observed when the HCl solution is added to the sodium thiosulfate. So throughout the laboratory notebook, we're emphasizing the investigations approach. And this is in keeping with what is laid down in the new syllabus. Next slide. So please, Oliver. Connor, sorry. So how is practical work examined? It doesn't matter whether the experiment is labeled as an investigation, primarily in the curriculum, or not. Both categories of practicals are examined in the same way. So what I would certainly recommend is that all lab practicals in the Chemistry Live lab notebook should be completed by students. And we'll see now in a moment the reason for this, because there is such a high occurrence of practical work throughout all 3 sample papers. Now, there are videos of all 27 experiments, and in case I forget at the end to thank Folens, Folens gave us outstanding support on these. We realise that both teachers and students like to have videos of the experiments. In some cases, they're used for revision. In other cases, they're used to demonstrate practical skills, and some teachers use them for both. But Folan sent down a team with video cameras, and they spent 2 weeks with us in the Eureka Centre. So now all of these 27 experiments are online. And I would like to thank Folens, because I realised that it's very expensive having video crew in the labs. But I have no doubt you'll be delighted when you see the final product. Next slide, so please. Now, in the unifying strand, they mention specifically words like accuracy, precision, and the selection of suitable equipment. Now, it's important when reading the specification that you don't just read the individual learning outcomes, but that you also read it in conjunction with the unifying strand, which is like a thread or a theme running through the entire curriculum specification. So we took this on board very much so. And in the next slide, please, Connor, you'll see some changes. So, for example, when students start volumetric analysis for the first time, we're very much emphasizing the selection of the proper apparatus, because as we'll see, this turns up on the exam papers, and to make sure that students have a great understanding of each of the items of apparatus used in volumetric analysis. So we've integrated the unifying strand into the laboratory notebook at the appropriate places. The unifying strand isn't something that you do and finish with it. It's something that we need to integrate into our teaching. So on the next slide, Connor, just to focus in, we'll see that with the graduated cylinder, emphasizing the idea of approximate volumes, the graduation marks, and so on, and what to rinse it out with. Now, this also will come in very much with random and systematic errors, which are dealt with in detail in the textbook. Likewise, in the volumetric analysis, rinsing it out with deionized water, a definite volume, making sure that you invert it, that won't accept in marking scheme shaking, it must be inverted and so on. And the reason for the narrow neck. And on the next slide, please. Okay, we again integrate into the laboratory investigations notebook, the key points about the pipette and the key points about the burette, because we can see questions on these being asked on the examination paper. And on the next slide, please, Connor, again, emphasizing the conical flask, why it has a particular shape, the reasons for washing down, rinsing only with deionized water, and what errors would be caused if it was rinsed with the solution it is to contain. So bear in mind those 2 groups, accuracy and precision, and random and systematic errors when teaching volumetric analysis. And next slide, please. To test then that the students have a good sound knowledge of accuracy and precision and so on, we have in the assessment and exam guide lots of these questions, simple MCQs, as is shown on the slide there, on page 67 of the assessment and exam guide. And on the next slide, please, we show some more questions, again, testing the students' knowledge and understanding. So everything is interconnected. It really is a teaching package. The textbook, the assessment and exam guide, and the laboratory notebook, all working in sync with each other. And on the next slide, then, please, Connor, we will at future webinars be zooming in because I'm always delighted to hear from teachers. And I realize that some teachers have had problems with the oxidation of phenylmethanol, and we'll be addressing what can possibly go wrong in that. The preparation of soap on a small scale is completely new, and we will be going through that bit by bit, step by step. And also preparing an ester using a reflux method. We'll be telling you what ester worked best for us in the lab and which one we videotaped and what esters to avoid because they don't give such great results. We can't cover these tonight, but we will be covering them in future webinar. Great. Next slide then, please, Connor. So let's zoom in now and just focus on the practical work that will be examined as exemplified on the 4 written sample papers that were published in April 2025. So on the next slide, let's see what sort of practicals turn up. Well, in sample paper 1 on this slide, you'll see number 1, determining the percentage of elemental iron. So experiment 12 turned up. And in keeping with the unifying strand, almost a full blank page was allocated, asking questions to describe how an exact volume of the solution can be made up. Now, there's one thing that I learned when marking Leaving Cert papers, and I marked Leaving Cert chemistry papers for over 20 years. When students are writing an answer like this, the first thing they should write is number 1. And every step should be 1, 2, 3, 4, because that forces the students to think in a logical sequence. It's terrible when students just start writing an essay. We did this and then we did that, then we went on. Get them to write 1, 2, 3 and leave a blank line between the end of number 1 and the end of number 2 so that if they forget something, they could stuff it in. And always have some sort of a labeled diagram, because I've seen so many students that were very near a H1. They forgot to mention something in the written, but I was able to give them the marks because they had it in a diagram. So always get them to describe the sequence of steps in 1, 2, 3, 4, number each step, in other words. And that is what we've done throughout the laboratory investigations notebook. Okay, so preparing an ester using a reflux method and the advantage of refluxing. Preparing soap, identify the reactant. So they need to be very careful that they look at the list of reactants for each experiment and the list of apparatus. That comes up time and time again in the sample papers. The next one then was on one of the new experiments, constructing a galvanic cell, experiment 21. I explained the operation, and your explanation should identify which species is oxidized and which is reduced. Again, vital to put in a label diagram. So there's 4 experiments so far. Right, next slide, please. The 5th experiment that turned up on the SEC sample paper investigating the rate of decomposition. Now, the types of questions were very similar to what we've seen in the past. Here's a new one, calculating the average rate. They were never asked to do, that's from the old one, the average rate and the instantaneous rate. But a new one that they could possibly ask, because it wasn't on the old syllabus, but it is on the new syllabus, calculate the initial rate. And we cover that in the textbook, so bear that in mind. So they could be asked to calculate the average, the instantaneous, or the initial rate. Okay, acid-base titrations, experiment 10 turned up, standard solution. And again, look, naming the piece of equipment. Number 7, the preparation of ethene, very similar to what was in the past. And again, very much what do you observe? So in keeping with what we have in the laboratory notebook. Next slide. So 7 questions. So next slide then, Connor. How many experiments turned up on paper 2? The concentration of ethanoic acid. Now, this was a very detailed question, similar to what we're used to in section A. But note the big difference in how practical work is now examined. Whereas in the past, the practicals were the first 3 in section A. Now the practicals are embedded throughout the pages. And it's interesting, if you look at the page numbers, every few pages, there's a question on practical work. So never before was practical work so important, and never before was it so important to have a laboratory notebook in which the students will write up the results of their experiments. So a very detailed set of questions on that. So that was like the third experiment, right? Next slide, so please, Connor. Experiment 4 then, measuring the relative molecular mass of a volatile liquid. Now, they didn't, interestingly enough, ask for the full details of the experiment. They just asked the students to calculate the mass of the propanol 1 vapor. But we can expect to see that coming up again. The 5th experiment that they examined in sample paper was the synthesis of benzoic acid. And again, the, experiment number 27, they asked about things were identify the base, the reactants that you used, describing the color change. How can you confirm that the benzoic acid was pure? And of course, calculating the percentage yield as we've seen. So benzoic acid was very similar, and I would certainly recommend, when you're doing the experiments from the old curriculum, make sure you get the students to attempt the questions in the assessment and exam guide and at the end of the chapter in which this experiment is located. Because when we had finished writing a chapter, we went through all the past exam papers and included as many of them as possible. And again, full marks to Folens. They allowed us to produce a very large, what we used to call the workbook, but a very large assessment and exam guide, because it's a lot more than a workbook. So you don't have to go back searching through exam papers. We've already done that work for you. And the past exam papers, they're all indicated by LCH in the textbook and in the assessment and exam guide. And make sure you get the students plenty of practice, because as you can see with those questions, they're very similar to the ones that have turned up in the old syllabus. Right, next slide, please, Connor. Grand. Okay, experiment number 6, investigating the effective surface area, carrying out the flame tests, detecting the presence of anions in aqueous solutions. So in sample paper 2, higher level, you had 8 experiments examined on the paper. And on the next slide, I've just summarized for the ordinary level. The same pattern is maintained in the ordinary level papers. A lot of experiments throughout the exam paper. So they had the displacement reactions, titrations, number 3, flame tests, testing for anions, enthalpy of reaction of neutralization, distinguishing aldehydes and ketones, effective surface area, preparation of ethene. 8 experiments. And in sample paper 2, again, 8 experiments, synthesizing benzoic acid, percentage of elemental iron in an iron tablet, electrolysis of acidified water, flame tests, ethene, iodine thiosulfate titration. And remember, all experiments now are for all students. They're no longer higher level and ordinary level. Standard solution of sodium carbonate, aldehydes and ketones. Okay, so again, 8 experiments. So great emphasis on practical work. And on the next slide, Connor, I'll hand over now to Ryan, who'll bring you through the online resources. Thank you, Ryan.
Thank you, Declan. Hello, everybody. And for the remainder of the session, we are going to talk about updates on online resources, followed by some questions and answers. So Connor, would you mind moving to the next slide for me? Thank you. So I wanted to start off with the scheme of work. The scheme of work is already up on Folan's Hive, as many of you are aware, and this is the proposed scheme of work that myself and Declan selected, and essentially it dictates what chapters are prioritised for online resources. So when I'm discussing the online resources later on, you'll see that I'm going to make a clear distinction between fifth-year chapters and sixth-year chapters. And where this distinction is coming from is from the scheme of work that we've selected here. Connor, would you mind moving to the next slide for me? Thank you, Connor. So as Declan mentioned already, the experiments, they are appearing in exam papers, in the 2 sample exam papers that we got, one at higher level and another 2 at ordinary level. There's quite a lot of experiments. There's quite a lot of emphasis on experiments, probably more so than many people realized within those papers. Poland, as Declan mentioned already, went to considerable effort to ensure that experiment videos are created and they are curated by myself and Declan, and that they're available for students and teachers. And the full set is available on Folan's Hive, but in addition to that, you will see QR codes in both the textbook and lab book, and they link to the video as well if that's an easier way of accessing the videos. But they are all available on Folan's Hive, and you'll see that the new experiments, as Declan outlined, they are also all available on Folan's Hive to view at your own discretion. Connor, next slide, please. So the PowerPoints. The first iteration of all the fifth-year PowerPoints, according to the Folan's scheme of work, are completed, and they're already available on Folan's Hive. It is a first iteration. I'll be discussing future iterations in a couple of slides' time. But you can see here one of the best things about these slides is that they marry up to the textbook very well. So for instance, many of the slides created have page numbers, and those page numbers correspond, as for example, page 40 correspond to page 40 within the textbook, so that teachers and students can use both the presentation, the PowerPoint, as well as the textbook in unison. Next slide, Connor. These next 2 slides, this one here and slide 28 in a moment, you'll see that many of the slides contain professional artwork. These were artwork that's been curated by Folan's to ensure that the best of images and best of explanation by diagram can be achieved in chemistry. So you can see here we have a simple one there, and Connor's moved on to the next slide. Yeah, that's perfect, Connor. If you want to move on, that's excellent there. So we have the continuum of chemical bonding, and these slides have been, like the artwork there, all professionally created and again curated and designed by Declan and myself, and they're all included inside the PowerPoints, as they are in the textbooks also. Next slide, Connor. So just a roadmap, as I discussed earlier in the previous slides there, that these PowerPoints are only a first iteration. Once I have completed all the PowerPoints, essentially what I will do is I will return to the PowerPoints, the fifth-year PowerPoints as such, to make them more interactive. Example including the likes of videos and other online material, as you might be familiar with my previous work. I would aim to be completing the sixth-year PowerPoints sometime during January to April. And then, as I was saying there, over the summer, I will have time to return to the PowerPoints and improve on them. In a previous webinar, you saw me discuss Canva presentations, and these are being developed, and many of them are completed already, and that they will be ready for 2026, 27, once the official PowerPoints are completed. And again, in terms of iterations, even after the summer of 2026, I'll be returning to the PowerPoints on a regular basis, and I'll be continuing to update these in light of the SEC exams. So once we see some more exam papers start coming out and we see the type of questions being asked, I'll be able to curate the PowerPoints accordingly. So it's going to be an online process as such. But for right now, what I'm trying to do is I'm trying to get the foundations, a strong foundations in the both 5th year and 6th year PowerPoints done first, and then I will return to these PowerPoints to make them more aesthetically pleasing and include other online resources. Next slide, Connor, please. So just a few things that teachers might not be aware that are available at the moment. So there is an equipment list available. The equipment list has been designed so that you can have both the experiment on the right-hand side of the column. So you can see, you can filter by experiment essentially, and also contains a description there. And of course, this is downloadable and editable for teachers. Lennox have been very good, and they have provided codes for each of these, so it makes this an easy access to using Lennox codes to order chemicals and equipment. And the chemical list is on the next slide here, and it's the same process again. The experiments are mentioned on the right-hand side. Sometimes a chemical might be used for multiple experiments. Example, sodium hydroxide. So you can see there again in terms of what the recommended purchase quantity is. And again, the codes for Lennox are there, and you can edit these to your own discretion within your between yourself and your colleagues in your schools. Next slide, please, Connor. In addition, this is already available online, but just to make sure people are aware of it, the chemistry lab reagents in terms of how to prepare these reagents. This was there previously in the 2nd edition. However, we've essentially jazzed this up a small bit here in terms of discussing how it's prepared, but also how it's the safety aspects and the storage aspects of it too. So this might be something that would be, well, it is something that's very relevant to all of us when it comes to safety and how we store our chemicals when it comes to our labs and so forth. So that's included for all chemicals that are required by the experiment for the due specification. Next slide, please, Connor. Now, the next couple of slides will be discussing, the numerical answers and solutions. So there is a slight distinction here. The numerical answers are literally just numerical answers, as you can see here. And we have numerical answers for both the textbook, and of course we have numerical answers for the workbook as well, as Connor just showed here. So just to clarify what has been achieved so far. So all numerical answers for the textbook, it has already been published onto Folens Hive, and that's available now. The numerical answers for the workbook, all the chapters for the 5th year scheme of work, that's already uploaded, or that's already provided to Folens, but some formatting needs to take place before that is uploaded onto the website shortly. So they're the numerical answers, and again, I will be working on these numerical answers over the upcoming months to ensure that all numerical answers for both the textbook and workbook are available to teachers by the end of year. Next slide, please, Connor. So the next part is the solutions. Now, the solutions naturally take a little bit longer to do than the numerical answers, because of course you've got to make them, you've got formatting issues, and it takes time to do out every single question, mathematical question in Chemistry Live. So most chapters are actually already completed, and several of them are already uploaded onto Folens Hive, and more will follow in the upcoming weeks. And then for the workbook there, Connor, next slide, thank you. All chapters are actually completed now for 5th year according to our scheme of work. So that's the bulk of the calculations actually, because of course you've got all the volumetric analysis, you've got the stoichiometry part 1 essentially, and you've also got the law of conservation. So that's the bulk of the solutions are actually presented or are already presented to Folens, and Folens are updating this onto their website, and they have to do a small bit of formatting, but that should be available shortly. Next slide, please, Connor. So just to clarify a few things regarding the online resources. Okay, the solutions for the textbook and workbook. So my aim is actually to ensure all the mathematical solutions for the 5th year are provided, and that's already been done for the workbook and the the textbook. I just need to do a little bit more to make sure that everything is in order for that. But that should be done fairly shortly. And then I will move on to the 6th year material. The PowerPoints. Again, the aim is to ensure that all PowerPoints go up onto Folens Hive, and then I will go through the PowerPoints to give them a fresh paint of coat, coat of paint, I should say, over the summer. And just a reminder that according to our scheme of work, all the PowerPoints for 5th year material is actually already uploaded onto Folens Hive. And then when it comes to the additional content, there is actually quite a number of additional resources that I have created and I am developing currently. I just need the time, I suppose, over the summer, or at least a break such as Easter and summer, to complete these and tidy these things up. But you'll see in August, late August, when schools open again, that Chemistry Live will contain quite a lot more additional content there, and I'll be discussing that additional content in a future webinar. Next slide, please, Connor. So as you might have seen already from both the biology webinar from Folens and the physics webinar yesterday from Folens, that there is that we're doing a Leaving Certificate 5th year examination for Christmas, and myself and Declan will be completing creating a exam for teachers to use. The exam will be editable, so that if you want to add in your own questions, you can add in your own questions. If you want to change things up, you can change things up. But this should be available for teachers and uploaded onto Folens Hive within the next 2 weeks. Yes. Connor, next slide, please. Now, we received a few questions prior to this webinar, and these questions are going to be addressed now. And I think the first question, Declan, you are actually going to address. So I'm just going to mute myself now.
Great. Thanks very much, Ryan. I was delighted that Folens forwarded me the list of questions. And this was a very interesting question. And I'd like to thank the teacher who submitted it. Do students need to know the discovery of each subatomic particle in detail? It isn't on the specification, but it is in the book. Now, this is something we need to be very careful about, how we read the specification. We need firstly to, of course, look at the learning outcomes. And the learning outcome was evaluate previous models of the atom against the current model with the assumptions and limitations. We need to cover the nuclear bar orbital models with the assumptions and limitations. And we also need to look at the properties of the proton, neutron, and electron in terms of mass, charge, and location. Now, as mentioned earlier, we also need to look at the unifying strand. So it's not just the learning outcome. We need to see how the unifying strand feeds in to that learning outcome. And the unifying strand emphasizes the importance of models and the limitations of models. And also the unifying strand stresses that we should emphasize in our teaching how scientists work and how scientific ideas are modified over time. And we've seen all of these appearing on the sample papers. Now, let's look at how we reflect those three things: the learning outcomes, the understanding about chemistry from the unifying strand, and how scientists work, how those feed in to dealing with this topic. Next slide, please, Connor. Now, clearly the nuclear model of the atom needs to be covered, and covered in some detail. Now, in order for students to understand the nuclear model and why it was such a huge change from previous models, they would have to cover what model existed prior to it. So hence the plum pudding model is covered directly ahead of the nuclear model. And remember, there are two nuclear models because, of course, when Rutherford put forward his nuclear model, the neutron hadn't been discovered. So on the next slide, please, Connor, we look at the assumption and limitation of Rutherford's nuclear model. Now, they were very clear on the exam paper. They even gave a picture of Rutherford, as we'll see in a moment. So the assumptions of Rutherford's nuclear model, the 4 assumptions, and the 2 limitations are covered there. Right, on the next slide then, please, Connor. We now have to move in to the updated nuclear model, where the proton was discovered, and this model now has both neutrons and protons. So the discovery of the neutron would have to be covered in order to give students an explanation of the updated nuclear model. That's the model that we have here at present. And I would see no problem if the examiners were to put a question, why was the neutron so difficult to detect? And it was difficult because it was neutral. So it wasn't affected by electric or magnetic fields. So without a doubt, the discovery of the neutron has to be covered. Right, on the next slide, then, Connor, we see the SEC exam question. So students will have to read the exam question very carefully to see, is it Rutherford's model or the Rutherford's nuclear model or the updated nuclear model that is being asked for. And, we give a sample answer there about Rutherford's nuclear model for the students. Again, bullet points are ideal when you're giving a detailed description like this. Now, on the next slide. Now, these 2 pages are the introduction to the Rutherford's nuclear model. You couldn't just pick the nuclear model out of thin air and present it to students without giving some bit of background as to where the electron came from. On the new curriculum specification, if you recall, they indicate that students must understand about the charges of the subatomic particle. So, for example, I'd see nothing wrong with a question where students would be asked, what evidence do we have that the electron is negatively charged? The evidence we have is because it's attracted to the positive plate in the discharge tube. So these 2 pages satisfy the role of introduction to the nuclear model. In addition, the pages show the contribution of famous scientists to the development of the nuclear model. Now, students do not have to learn off any details about scientists. But what is good about the sample papers, and I would congratulate the SEC, is that throughout the papers, they do follow the unifying strand in reflecting the work of various scientists in contributing to various discoveries and the development of various models. So a very good example was in the development of the lithium-ion cell, where they started with the 3 scientists who were awarded the Nobel Prize for inventing the lithium-ion cell that we have inside in our mobile phones. So that is why throughout this introduction, I include a small little summary of the scientists, as well as showing how models change with time. So here, the model of William Crookes, where he thought they were just cathode rays, and then the discovery that they weren't rays at all. They were actually particles consisting of electrons coming from the cathode. So that's the reason why these 2 pages summarizing atomic structure lead in to the nuclear model. And so I think it would be essential for any teacher to give students this introduction of 2 pages to the development of that model. Grand. And next slide, Connor. Okay. So this brings us to any remaining Q&A questions that may have arisen in what was forwarded to Folens or during this webinar. So I'll hand back to you, Connor, if you would like to field any questions that are still out there.
Perfect. Thanks so much, Declan. Thanks so much, Ryan, for that. I see Ryan particularly has been busy in the chat responding to a lot of questions. So I think there's maybe a couple of more specific ones that we won't address now because we're a bit pressed for time. But one of the big questions that came up in the chat was just people asking for asking about the laboratory investigations notebook and when that might be available. Well, it's obviously out. It's in our warehouse. It should be in bookshops now. So as Emma, our sales manager for post-primary, head of sales for post-primary, mentioned that our sales reps should be visiting schools over the next week or two and dropping in samples of that book if you don't already have it. But also, if you'd like to find out more about that book or have any other questions about Chemistry Live, you can go to folens.ie where you can search for Chemistry Live to find out more about the teaching package. But also, if you'd like to post any questions you might have about it to our customer service team, you can do that through forms on the website. Or if you'd like to contact your local sales rep, you can also search for them through the website by entering your school information, and that will put you in touch with the Folens rep who looks after that part of the country. I know we're nearly finished now, Declan. There were just a couple of questions that I know did come in prior to the webinar, which we might just quickly tackle now before we wrap it up. So if I'll throw the question out perhaps, and either yourself or Ryan can take it. So the first question asks, do you need to get students to completely write up experiments after they complete them, or is this a matter of preference?
I can jump in there, Declan, if you like. It's good practice to have students write up the laboratory investigations. Some students or some teachers have students write up these experiments throughout the experiment as it's been carried out, and some people do it at the very end. Thank you, Connor.
No problem. Next one is on anion equations. Do they need to know phosphate and nitrate equations?
Yeah, no, definitely not. They're quite complex equations. They need only know the results of the tests, not the balanced ionic equations. No.
Okay. And I know, Ryan, you tackled some of the questions about experiments 21 and 22, whether they were all of the experiments associated with those were necessary, which you said they were. And I think you answered also the question on esters that came through. I suppose sorry, Ryan, did you want to say something on that?
No, sorry,
okay.
Connor, work ahead.
Okay. The other big thing, I suppose, which we don't really have any answers to, but it has come back from a lot of teachers, and it was one of the things that was quite a common question thread, was to do with the project and the AAC. So I don't know, Declan or Ryan, whether you'd like to talk a little bit about your take on that currently and how we might plan to support teachers for that piece of work over the next months, as I suppose we gain more clarity on what the project might involve.
Yeah, I can take that question. We will, of course, be covering the AAC in due course when we have more information. I would expect most teachers will start tuning into it in 6th year when we have the final wording, and also hopefully we'll have some sort of sample marking schemes to guide teachers on what is required. At the moment, the breakdown of marks is very vague, and therefore it is impossible for any teacher to say with certainty what exactly would be required in the write-up. So I think the best approach to take is to wait and see what comes to us from the SEC.
Okay. Thanks, Declan.
Yeah.
Okay. So I think that that's pretty much all the time we have. I said that we'd complete it in under 45 minutes, so I lied. It took us a little bit longer than that, unfortunately, but I hope you found it useful. Declan and Ryan, thanks again so much for such an informative presentation. And I'd like to especially call out Sarah from marketing, who's done great work behind the scenes tonight, and also the other members of the marketing team who've helped to promote Chemistry Live over the last weeks and months. That's Indy and Katerina. They've given us great support throughout the promotion of the third edition. And last but not least, of course, to everyone who's joined us this evening. It's always a busy time of year. It's never not a busy time of year for teachers, I believe. But, you know, it's another hour of your evening that you've given up to attend this webinar. So we really appreciate your time, and I hope that you found it beneficial. Just one small favor, if you don't mind, before you clock off, there's a very short survey that Sarah is going to share the link to in the chat, and it only will take a minute for you to complete. It'd be really helpful to hear what you'd like us to cover in future webinars. So if you could let us know about that, as Declan mentioned, we obviously have topics that we'd like to cover in future webinars, but we can obviously tailor them to your needs and requirements. If there's specific things that you'd like to suggest in that questionnaire, we'll make sure that we cover it in future webinars. As I said, you'll receive an email tomorrow sharing the links to the webinar recording and also the presentation. And then over the next week or two, as soon as we can, produce that Christmas exam paper. We will circulate that to you also as people who've registered and attended tonight's webinar. So I think that's pretty much it. I think all that remains for me to say is to thank you again for joining us. Thank you, Ryan. Thank you, Declan. We hope you found this a helpful webinar, and we hope you also enjoy the rest of your evening. Thanks very much. Take care. Bye-bye.